Probably here.
Okay, so this is what we talked about last chapter. Okay, so this would be an example of a histogram for a binomial probability distribution, and a binomial probability distribution is a discrete distribution. Okay, because the value of x could only be certain values, 0 or 1 or 2 or 3 or 4 or 5 in terms of the number of successes, right? So here would be the table for it, here would be the histogram for it. What's the total area, again, of the histogram?
The standard deviation times the midpoint.
No. What would be the total area?
Oh wait, it's the side number times the number of the block that you're in.
So the width would be 1 times the probability. So this would be the probability. So we take the width, 1 times the probability, plus the width times the probability times the width times the probability times the width. What would you get if you did that? 1. Because what's the sums of the probabilities? 1. So if you took a width of 1 times the probability, that'd be the area of this, right? Let's look at a couple of them here. Let me do this. Come on. So what I'm saying is that this is a width of 1, and this is a height, in this case, of 0.07. So the area of this is 0.07. This is a width of 1, and this is the probability of 0.23. So this is area of 0.23. So what do you think these areas add up to? 1. Okay. So the sum of the areas is 1 because the sum of the probabilities is 1. Okay? So I told you last chapter that every probability distribution has an area of 1. Okay? Now that's the same whether it's discrete or continuous. So this guy right here is going to be what we work with, and I'm telling you that the total area of this is 1. Okay, so this is a continuous distribution, okay? Just like the last one was discrete, but it's the same sum of the areas. The area is still 1, okay? So we're moving to continuous now. And again, a continuous random variable has an infinite number of possible values that can be represented. So you can't just have x being 0 or 1 or 2 or 3 and finding areas above 0 and 1 and 2 and 3. We can't do that anymore. Okay? We got to look at all kinds of values, fractions, all kinds of possible values. So we're moving into a continuous distribution. Okay? So the first continuous distribution, and probably the most important one, is going to be a normal distribution. Okay? So in a normal distribution, the mean, median, and mode are all the same. And where are they at? Right. So whatever this guy is here, this value on this axis is, that's going to be your mean, median, and mode. They're all the same thing. Okay? So we call this a bell-shaped distribution, and it's the same on the left as it is the right. That's an important idea. It's the same amount on the right as it is the left. The total area of the curve is? 1. The normal curve approaches but never touches the x-axis and extends far, far, far away, and it gets really, really close as you move way to the right and way to the left. And again, the total area is 1. Let me show you this. That when you're working with probabilities and you find probabilities, last chapter you might have done this, right? Okay? Today, in this chapter, you're going to do this. you're only going to be able to find areas not of a specific value, but values of this variable that might be above 2, or might be below 2, or might be between 1 and 2. So we're going to be looking at like intervals of x. Okay, and again, last chapter they could only be whole numbers. Now they can be 2.1, 2.2, 2.3, 1.9, 1.6, 1.97. Okay, so we are going to have a lot of decimals that these can be equal to, so you can't find the probability of a particular value anymore. You have to find the probability of a range of values. So get in the habit of writing this, is what I'm saying, and I'll help you with that. Okay, so now we've talked about a normal distribution, and this is kind of a review of that a little bit. Okay, so here's our mean, and I'll use the values that we used before for the example of an IQ. The mean of an IQ test is 100, standard deviation is 15. So this value here would be 100. This value here would be
115.
So this is a value that is 1 standard deviation above the mean. This is 1 below the mean. This is 2 below the mean. This is 2 above the mean, right? What did we call, let's read this, I guess. So between mu minus sigma and mu plus sigma, the graph curves downward, okay? The graph curves upward to the left of this value and to the right of this value. The point at which the curve changes from curving upward to curving downward is called? You remember that? Inflection points. So there's 2 inflection points. And again, on the x-axis below that inflection point is the value that is 1 standard deviation below the middle and 1 standard deviation above the middle. Okay? And what percent of the data is within that range?
68.
Right. And 2 standard deviations?
34.
Well, it'd be 34 from here to here.
Oh, wait, 95.
95, right. So anything that were to fall more than 2 standard deviations above the mean or below the mean would have a probability of occurring with a total of 5% of the time. So we would consider that to be an unusual event if it fell more than 2 below or more than 2 above. Okay, that 5% thing. So now we're going to look at some different possible shapes of some different distributions. This is something that I can use to just kind of show you a bunch of different ones here. I should have made this active for you guys on your iPad, but I didn't. So what's the mean of this distribution, do you think?
1.
1. What do you think the standard deviation is?
1. 2.
2. So this is the thing that changes the standard deviation. So if I make it bigger, I make it more spread out. I make that inflection point further away. So if I make it a mean of 1, a standard deviation of 1, then this is my inflection point here. So let's make the mean something different. Does the shape change? It changes position, but it doesn't change really the shape, does it? So here we got a mean of 4. Standard deviation of 1, let's make it a mean of 4 with a standard deviation of 2. So if the standard deviation is a little bit higher, it's not clumped quite as high, and this isn't quite as high here, right?
So the inflection points would be 6 and 2.
Would be 6 and 2, right. So let's see if we can draw some examples of some distributions with this mean and this standard deviation, okay? So let's scale out our paper here. Get some tick marks. So let's make 10 about right here. And let's scale it by 2's. So I'm going to put a line at the mean that's about this high, and I'm going to try to make my inflection point 2 units to the left. So I'm going to draw a curve and try to make it start curving up about there. And I should be drawing it a little, it should be getting closer. I didn't do a very good job of that, but I don't expect you guys to be perfect either. Maybe I'll go a little lower. And then try to make it symmetrical on the right. Now, the next one, I wanted to have a different mean but the same standard deviation. So I'm going to try to make this height about the same here at 6. So I'm going to try to make the same graph centered around 6 as this was around 10. I'm going to try. So now, like we said before, the inflection points are at 4 and 8 instead of 8 and 12. So it's not perfect, but it's close. I'm trying to make them the same shape. Just slid to the left. Now the next one, I'm not going to make the height the same. I'm going to make the height a little bit different because it's going to be more spread out. So I'm going to try to make my inflection points at 4 units to the left and 4 units to the right. So the standard deviation is 4 now. It's more spread out. So we're trying to understand normal distributions a little bit, which we've had some experience. And then we will solve some problems today with it. And we'll get into that. We'll use our table in the back to solve our problems. Okay? So if you have your book open, look at the table in the back. What's the mean and standard deviation of that distribution, do you think?
Which one?
The one on A16 and A17. What's the middle? 0. And I'm going to tell you that the standard deviation is 1. Okay, so when you have a distribution that's normal and has a mean of 0 and a standard deviation of 1, we call that a standard normal. Okay, so the word standard means what?
0.
Mean of 0, standard deviation of 1. That's what standard means when you add it in front of the word normal. Notice the label on the x-axis. What is the label on the x-axis? It's not an x anymore. It's a z. Okay, so now we're going to talk about z-scores. Okay, so there was a formula that we talked about when we calculated the z-score. You may remember it.
The high minus.
I'll tell you this, that the z tells you the number of standard deviations from the mean that value is.
Okay, so it's over the mean then.
No, it's over sigma. The denominator of the formula is sigma. The numerator is x minus mu. So x is the score you're trying to convert. Okay, x is the raw score. And you'll see that in a second. X is the raw score. Okay, Mu is the mean of the original distribution. So like the mean of the standard or the IQ is 100. The standard deviation is 15. So what's the z-score of 120? Well, what's the raw score? 120. So it's going to be 120 minus 100 divided by 15.
1.5.
Well, it would be 20 divided by 15. And that would be 1.33. Z-scores go to 2 decimal places. Okay? Always make your z-scores go to 2 decimal places. If you looked in the back of the book, the z-scores are going to be always calculated to 2 decimal places. Okay? What does this mean again? What does 1.33 mean about 120?
How far away it is.
Right, the number of standard deviations above the mean in this case. If it's negative, it is below the mean. If it's positive, it's above the mean. So we have a positive z-score here. So this is above the mean of 100. Okay? Now, what the table will do is it will tell you what percent is below that z-score. So like, let me give you this discussion. So let's say that you score a 120 on your IQ test, or on your IQ test. What percent did you do better than? Well, the table will tell you that. Now, the table is a table of z-scores. It's a standard normal table. So what is the z-score for 120? We said 1.33. So the table will tell you what percent of the distribution 1.33 is above in the whole group. Okay. So just to kind of discuss that, let's turn to our table and let's look up 1.33. So here I have the table. Okay. And so here's a z-score to the tenths right here. So 1.33, or this is 1.3, and now you move to your hundredths. So this would be a z-score of 1.33, and that number right there is the area of this blue region. So the area of the blue region is 0.9082. So that means
How did you know
that, just let me tell you this and then I'll help you answer your question. This means that 90.82% is below that z-score and correspondingly is below that raw score. That's what that table will do for you. Okay, now let's look back at the table. Question.
How did you know to go to the 0.3 on top? Or the point, yeah, 0.0.
Well, what is my ones and tenths of 1.33? 1.3. What is the hundredths of my number 1.33? What's the hundredths unit? 3. 1.3. What's next? 3. So then go to the hundredths of 3. If it was 1.34, then you'd be here. If it was 1.35, it'd be here. If it was 1.36, it would be here. And again, what is this area? This is the area that is to the left of this. You guys see that shaded there? Okay, that's the area to the left, and that's the probability that somebody would be less than that value. Okay. So let's go to this page and let's talk about just a few examples here, okay? So finding areas under the standard normal curve, which is the same thing as finding probabilities as well, because area is probability. Probability is area, okay? So if I ask you this question, what's the probability that a random score is less than 1.23? What's the area to the left of a z-score of 1.23? You'd look it up in your table. So again, go to your table. And would you use this one or this one? Well, this is all negatives. These are all negative z-scores. And what are these areas all? They're all less than 50% because this z-score is to the left of the middle. Okay? These are all positive z-scores, and these areas are all more than 50%. Okay? So 1.23 would be right here. So what is the probability that a z-score would be less than 1.23?
982.
I would say it'd be a little different. I think it'd be 8907. Can you see that in your table? 8907?
Oh, that's what I meant to say. Oh, wait. Oh, 1.23. Okay.
So what's the probability that a random z would be less than 1.23? It would be this area to the left of 1.23, which is 0.8092. (8907) actually. Okay. So that's how you find the area to the left of a z-score. How do you find the area to the right? There's no table that will tell you that. The tables are built for area to the left. How are you going to find this area here then? Right. Subtract the total area of the distribution, which is 1 minus the area to the left of that z-score. Okay? So here we might be asking, what's the probability that a z is greater than 1.23? Okay? Now, initially, and on your assignments today, I want you to draw a picture. Okay? So if we want to know this, probability that z is greater than 1.23, you draw your distribution, and what's the mean of the distribution?
0, 1, 0.
Right? Mean is 0, standard deviation is 1, and we're dealing with z-scores, and a z-score of 1.23 is about there. And if we want to find this area here, we have to find this area, which we already know from the previous problem, and subtract it from 1. So 1 minus 0.8907 is 0.1193, I believe, or 1093. Okay. So the table in the back of the book tells you the area to the left of that z-score. Okay, if you want to find the area to the right, you got to subtract it from 1. Okay. Now, let's think about between. Okay. So I'm going to use an example that we talked about in the past. So Q3. Let's say Q3 is 100. What does that mean?
100 is like 75%.
75% is below this value, right? Okay. Q1 is 15. Okay. So answer me this question. What percent is between this value and this value? What percent is below, and this is, I'm going to do it like this, because we don't know it's necessarily a normal curve. But what percent is below 100?
75.
75, because it's Q3. Okay. What percent is below 15?
25.
So what percent is between there and there?
50.
50, right? So you're going to do the same thing here. Is if we want to know what's the chances that you would have a z-score probability that a z-score would be between, in this case, 1.23 and, not sure what this says, negative 0.75. You draw a picture. So draw this picture. 1.23 is where from 0? To the right. So put a 1.23 there. Do that. So put a 1.23 here. Negative 0.75 would be to the left of 0, correct? And you want to find this area right here. or the probability that a z would be between that value and that value. So here's what you do. You find the area to the left of 1.23 in the table. See if you can do that. We've already done it, I think, earlier in the problem here. Anybody know that number?
Is that the 1 point or the 0.1093?
I think it's this one here. 0.8097. Okay. Is it 8907?
Yeah.
Okay, so just ignore that for a second. 8907. What is the area to the left of negative 0.75? That one you're going to have to look up. And you're going to have to use this table to do it. So where am I going to be at? Negative 0.07, what's the hundredth? 75 was it?
Yeah.
So then that's going to be this value about right there. 2266?
Yep.
Is with me here?
Yeah.
So put that 0.2266 right there. So the area to the left of this is 0.2266. The area completely to the left of here is 8907. So what do you do with these?
Subtract.
You subtract. So 0.8907 minus 0.2266 is 1466. 0.6641. So that would be the answer to what is the area between those two, or what's the probability that a z-score is between this z-score and that one. Okay? That's today. That's it. Okay? So let's do this. Let's do a couple problems off of your assignment. So open up your book.
Are you jamming out in here?
Staying awake. Trying to stay awake. Okay, let's try on page 245, number 47. Here's how I'd like you to do it. I'd like you to draw a picture. No, because I don't want you to work on this yet. So number 47. So what's the probability that a random z would be less than 1.45? So I'm going to write the problem, and I'm going to draw a picture for it. I would put 1.45 right about there. And I want to know this area right here. So you look it up on your table. I want to see a picture though. So if you look it up on your table, tell me what you find. Everybody find that, 0.9265. And again, what is this? It's a probability. It's an area. It's the probability that a random z is less than that z-score. What if this would have been equal to? Then you'd add the area of this segment. What's the area of that segment? Nothing. Doesn't matter if it's equal to or not. We're finding area of the distribution. That has no area. So I don't care if it's even equal or less than. Doesn't matter. Okay? Let's do one more. Let's go number 50. Okay, so number 50, what's the probability that a z-score is greater than negative 1.85?
So we're gonna have to do the subtraction one here, right?
Maybe. I'll say yes. So negative 1.85 would be a z-score about here. Do we want to calculate the area to the left? No. To the right. So then we still have to look up that negative 1.85, but then subtract that area from 1. So somebody look up negative 1.85. Everybody do it.
0.256. No, 0.0322.
Everybody find that. 0.322. So this area right here, does that seem reasonable? 0.322. Does that seem reasonable? Yeah, because that's quite a ways to the left. It's almost 2 standard deviations to the left. So we got just a little bit here. So let's go 1 minus 0.0322.
0.967.
And so that's your answer right there.
So wait, why do you subtract 1?
Because this area here that you calculate in your table is the area to the left of negative 1.85. But we want to know what's the probability that a z is greater than 1.85, negative 1.85, okay? Area to the right, subtract your probability from 1, right? Area to the left, subtract your probability, don't do anything. Area between, subtract your 2 probabilities, okay? So now when I go between, here, do it like this. Draw your arrows like that, put your area here for whatever you calculate for that area, put your area here for this area, and then the area between is the difference of these 2 probabilities, okay? All right. Do these first. Do the ones at the end first. The other ones at the beginning are just answer, quick answer.
Are those the pictures?
Those are the pictures, and those are the ones like we just did. Yep. I'll tell you this: if you don't get the first chunk done, I won't count it against you tomorrow. I still want you to do it, but you need to get these done. These are just quick answer problems that I want you to go through that are vocabulary stuff that are important. These are more important.
Will we get our test back this week?
I would like to get them back to you Wednesday. Yep.